It's been a hell of a week on call already, and I hope I can get this finished before I get called out again. So today, I am going to just do a quick curiosity teardown on this super common, at least in North America, this is a really common style and brand of a lighting dimmer. This one was in service in my house for well over the 25 years that I've owned the place, so it doesn't really owe me anything, but the mechanical on-off switch part of it has died, so I just went to the store and bought a replacement. Oh, sure, now it works. Anyway, I'm going to tear into this guy and just see how much different it is from the absolutely most basic dimmer circuit, which is this little kit that I built, I don't know, a while ago. Anyways, I'll put a link to it up there. And it is basically, at its core, no more than a capacitor, variable resistor, a fixed resistor, not a dual diode, what are those things called? A diac, I think, and a triac to do the actual switching of the current. I'm going to guess that this thing, being a commercial product from a professional company, is going to have a little bit more going on inside it. It'll probably have some RF filtering, EMI kind of filtering, and MOV, maybe, fusing, maybe. I'm not sure whether you can see it through the paint or not, but it's rated at 600 watts, 120 volts AC, which you'd expect for a North American device. So that 600 watts is going to be more than enough for most residential applications, unless you're doing something really funky. You can get higher current ones too. Anyways, without any further ado, let's just open it up. Surprisingly, it has screws holding it together. I was expecting rivets or... Come on, get out. I was expecting rivets or tabs or something like that, and there are a couple of tabs, but that's what's holding the potentiometer on. This is much easier to get inside of than I expected. Oh yeah, the 3 wires. So there's the AC line in, AC line out to the load, and just a ground. And the ground, as you can see, is riveted right onto the case, which is also where, I'm assuming, the triac is riveted to the case as well, providing some heat sinking. That's good. So there is the potentiometer with its little switch on the back of it. Push on, push off switch, which, like I said, is working now. The line in and line out don't really matter which is in and which is out. They'll work the same. But let's just call this one the line in just for fun. That comes in through the switch. The switch has a couple of capacitors on its output side going down to... Looks like one of them goes down to one lug of the variable resistor, the wiper of the variable resistor. The other one goes to the one end of the variable resistor. The other end of the variable resistor goes nowhere. So it's not set up as a voltage divider. It's just set up as a series resistance. Then from the wiper to one tab of the triac, we have an inductor, just a series inductor, and then that goes down to one wire of that. Where is the output coming off? Oh, the output is also coming off that center wiper. Okay, I'm going to draw this out. It's even simpler. Actually, it has less components than this thing does. That surprises me. Yeah, let me just draw this out and I'll come back. Well, that didn't take too long to reverse engineer. Let me just zoom in on the schematic and show you what I found. It's not too surprising. So the AC line comes in, either in and out is kind of irrelevant in this circuit. Supply and load doesn't really matter which side it's on, but let's just assume for arbitrary reasons that this is a supply side. So power comes in through the switch, smoothing capacitor, 0.1 microfarads, 250 volts. And then across to another of the same type of capacitor, which goes down to the one end of the variable resistor. Now, that variable resistor, it is a potentiometer technically I mean, that's what the component actually is, but only 2 of the terminals are used, the wiper and one end. So it's just a variable series resistance. So the power also carries on to the one of the 2 main terminals of this triac, and it's not exactly a triac, but we'll get to that in a second. The power from the other side comes in, goes through that series choke or series inductance, this guy here, which is also going to be filtering and cleaning up switching spikes and stuff like that. That goes to main terminal number 2. And the gate is just controlled between this capacitor and this resistor here. Very, very simple. And as I said, more simple than this guy even. This guy has a second resistor in there. And it has 2 components instead of just this one. Now, originally I was calling that a triac, and it kind of is, but it kind of isn't. What it really is a quadrac, which is a triac, that, and a diac, that, in the same package. The diac doesn't conduct until it gets to a high enough voltage to trigger the gate of the triac. So that basically allows them to combine 2 components into one, save on part count, all the rest of that. I had a real bear of a time finding a data sheet on this thing, and the part number is not a part number that I could find a data sheet on, so I had to go on a wild goose chase. I actually ended up using the Wayback Machine a couple of different times, and finally landed on a modern equivalent, let's say, that is still in production, which makes sense because these things are still in production. Meet the quadrac. They are, as I said, a special type of thyristor combining a diac and a triac in a single package. I will link to this Wikipedia article, which will take you through to more theory on the diac and triac than you ever wanted to know. But as I said, the diac is for triggering the triac gate. Diacs are essentially a bidirectional diode that switch the AC voltage and trigger the triac or SCRs or other similar things. So they don't conduct until they hit their breakover voltage. So that gives the triac a hard on at a certain level of voltage rather than just slowly soft coming on, maybe not on, as voltage ramps up on the AC waveform. And here is a datasheet for a modern quadrac from the Littelfuse company. I'd forgotten that they actually make silicone. I thought they just made fuses, as the name suggests. So there is what it looks like. Oh, I labeled it gate. It's actually trigger because the gate is really this connection in here. Okay, regardless. And there in the data sheet is their sample test circuit. Does that look just a little bit familiar? Add in another capacitor there for filtering, add in a series inductor, and you've got what I've got sitting on my workbench. Wow. So the timing, as I said, is basically a combination of this resistor and this capacitor. That just selects how quickly this thing gets up to its trigger voltage on each half cycle, or each half of the AC waveform, as shown down here. And there from Wikipedia is just the voltage versus current trace of a diac in both directions. So positive voltage going up, the current is not really rising until you hit that 30-ish volt breakover. Then all of a sudden, boom, it starts conducting. Same thing in the negative direction, boom, there it goes. That was surprisingly simple. The hardest part was trying to figure out what that device was. I had never encountered that one before. But now that I have, I know a little bit more. I suppose I could, if I was really brave, take that potentiometer or that switch off the potentiometer apart and try and figure out why it's mechanically jamming up and being intermittent. But, like I said, it was less than $10 to replace it, and this thing gave me, 25 plus years of service, so it certainly doesn't owe me anything. I'm sure it's just a mechanical fault in there. It's just worn out from thousands and thousands of uses, so I'm not going to try and fix it any further. That was never my intention tonight anyways. I just was curious. And I hope if you were curious that your curiosity has been satisfied at least a little bit. Mine has, I know that. Thanks for watching. I know this was just a quickie, but sometimes that's what you get. Comments and questions down below. I'll talk to you later.